The plum pudding model of an atom was one of the most widely accepted models all over the world for understanding the structure of the atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led many scientists all over the globe to reconsider the structure of an atom and study it again. Around the year 1911, a British physicist, Ernst Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his experiment looked like. As we can see here, he used a source of alpha particles locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and travelled in a straight line. But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier as well. So if we say the atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier particles will pierce through the lighter pudding structure of the atom and pass through it. This is what Rutherford thought. For this reason, their greater mass and energy compared to the protons made him choose alpha particles for the experiment. Next, he used a very thin gold foil on which the alpha particles would bombard. Why did he choose a gold foil? Well, a really thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more convenient the experiment would be. Lastly, are we able to locate this circular band with a gap here? What could this be? Well, this is a screen. A fluorescent screen that would help us detect the radiation. That means the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this is how the track of alpha particles can be traced. Now we're all set to understand how the experiment worked. The alpha particles were emitted from the element present in this box. These directly hit the gold foil. Now what should happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. That means it is expected that the alpha particles will pass right through the atoms and hit the detector straight. And why so? Because the mass of alpha particles is heavier than the mass of positive charges. That means they should directly hit the atom and move ahead through it. Only a very small deviation would probably be acceptable in this case. But is this what he observed? Not really. He was astonished to get unexpected results. What results did he get? He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct. Based on the conclusions he had, he put forward the new hypothesis explaining the structure of atoms. What were his conclusions? Let us have a look at the conclusions by Rutherford, followed by the new atomic model put forth by him in the next video.